Okay, so find all real numbered ordered pair solutions to this problem over here. And this was on Reddit. Certainly if you look at the Reddit thing, you'll see a variety of people chiming in about how to do it. I think these are probably the two most popular ways of doing it. One is to realize that there might be some factorizations in the problem. And one way to do that is to multiply both sides by 2. So if you do that, you're going to get 2x squared plus 2y squared minus 2xy minus 2x minus 2y plus 2. And then what you start to realize is that, that could be written as x squared, let's see, minus 2xy plus y squared, all right? Now someone says, what's left over there? Quite a bit's left over. I'm still getting x squared and a y squared. And let me write that down for you now. So I still get x squared and y squared left over. And what else is left? I got the, let's see, I got, minus 2x. I have minus 2y left over. And then I got this plus 2 in the end, so I can say plus 1, plus 1. Then I start to realize over here that this all has to add up to 0. And these are all perfect squares now. What's the first guy going to be? That's going to be x minus y squared. What's the next guy going to be? X minus 1 squared. What's next guy going to be? Y minus 1 squared, and that's equals 0. And here's the deal. I'm looking at something being squared, something being squared, something being squared. These are real numbers, right? So if they're real numbers, those things, if it's going to add up to 0, would all have to be simultaneously 0, by the way. What would make that occur? X equals 1. The other possibility is y equals 1. And that's going to make each one of these terms equal to 0. So there's only one solution to it. It's going to be an ordered pair 1, 1. That's one way of doing it. The other way of doing it is to realize it's quadratic in either x or y, all right? So what I do is I rewrite the equation in terms of x squared. So x squared, the next term would be this one over here, which would be, I factor an x over there and I get minus 1 plus y. And then this constant term over here, yeah, I know it's a variable over there, this over here. Use quadratic formula. What do you get? You get this over here. Not so bad. The opposite of this guy's coefficient, which is going to be y plus 1, plus or minus that guy's coefficient squared. Not so bad. And then the 4ac. All right? So that's not so bad. What's bad about this is simplifying it. All right, let's go through that. So y plus 1 squared, let's write this down for you. Minus 4, y squared minus y plus 1. It's going to be y squared plus 2y plus 1 minus 4y squared. Let's see, plus 4y, and then minus 4. Let's pull this together. Minus 3y squared. Let's see, 6y. And then minus 3. All right? That is where this is coming from over here. So minus 3y squared plus 6y minus 3. What I would be doing here is, I know it's a parabola, and this parabola opens downward like this over here. What's the vertex? Let's go through that. It's going to be minus 6 over twice the minus 3, which is minus 6. So it's going to be 1. And what do you get over here? Well, you plug a 1 in there, you get, minus 3. Minus 3 is minus 6, plus 6 is 0. So what do I know about this thing? It's always going to be negative except here. So it's got only one solution over there, and the y has to be 1. And the reason for that, I want this to be a real number, and the only way to be a real number is if y is equal to 1. The only way it could be real, by the way. If y were any other number, it's not going to be real. All right, not going to be real. So what do you get over here? Let's put this down. If y is 1, you're going to get what? X equals 1 plus 1 is 2, plus or minus. Well, if y is 1, this would be 0, this would be 2, and you get 1. Are we getting the same answer? We're getting the same answer, 1, 1. Thank you.